A strange object from deep space is racing toward Mars, and within hours scientists around the world will be watching closely to see what happens next. The object, known as 3I, Atlas, has already sparked intense debate because of its unusual behavior and mysterious green glow. Some researchers believe it is simply an uncommon interstellar comet, while others admit that a few of its features are difficult to explain with standard models. Unlike most comets, this object did not behave in a predictable way after discovery. Its brightness rose and fell suddenly instead of increasing smoothly as it approached the Sun. Spectral observations showed unusually high amounts of carbon dioxide while water signatures appeared weaker than expected. Several observing teams also reported large, slow-moving dust particles and bursts of activity that looked strangely organized rather than random. The green halo surrounding the object added even more mystery. Scientists tried to match it with known comet chemistry, but the color patterns did not fit comfortably into familiar explanations. Because of these combined anomalies, some observers quietly began discussing more unconventional possibilities, including the idea that the object could be artificial or engineered in some way. Now the object is approaching Mars, creating the most important observation window since its discovery. During part of the flyby, Earth-based telescopes will lose clear visibility because of orbital alignment. That means spacecraft around Mars will become the primary observers. Orbiters including Mars Express, MAVEN, and the Trace Gas Orbiter are preparing to monitor the object continuously. Instruments will track dust, radiation, charged particles, atmospheric disturbances, and any sudden changes in brightness or trajectory. Scientists are especially focused on three possibilities. The first is fragmentation. If the object breaks apart near Mars or the Sun, the pattern of debris could reveal whether it is fragile and icy like a normal comet or something far stranger. The second is unexpected motion. Even small unexplained changes in trajectory could raise important questions about what forces are acting on the object. The third is unusual spectral data. If orbiters detect emissions or particle signatures that cannot be explained by ordinary sublimating ice and dust, researchers may need to reconsider current theories. Mars itself provides a unique scientific environment for studying this encounter. Its thin atmosphere and weak magnetic fields could react measurably if dust or fragments pass nearby. Instruments may detect temporary auroras, ionospheric disturbances, or strange particle events. Even delayed telemetry from orbiters could provide valuable clues through isotopic analysis and dust composition studies. There are also concerns about contamination. If the object carries complex organic compounds or exotic carbon chemistry, some material could eventually settle onto the Martian surface. Future missions searching for signs of ancient Martian life would then need to distinguish native chemistry from interstellar contamination. For that reason, scientists are carefully documenting every observation with multiple independent systems. Behind the scenes, observatories and mission teams are operating under intense pressure. Engineers are preparing backup data routes while astronomers coordinate continuous monitoring schedules. Amateur astronomers are also playing an important role. Around the world, independent skywatchers have prepared automated systems to upload brightness measurements and telescope images the moment unusual activity appears. In some cases, the first important detection may come from a small private observatory rather than a major space agency. Several outcomes are possible. In the most conservative scenario, 3I, ATLAS turns out to be an unusual but natural comet with rare chemistry and unpredictable outgassing behavior. Even that result would dramatically improve our understanding of interstellar objects. A second possibility is major fragmentation, creating a cloud of debris that could temporarily affect spacecraft near Mars. The most controversial possibility is that the object displays behavior that cannot be explained naturally, such as synchronized pulses, coherent emissions, or structured movement inconsistent with ordinary comet physics. Scientists emphasize that extraordinary conclusions require extraordinary evidence. For now, the focus remains on careful measurement, transparency, and independent verification. Multiple telescopes, spacecraft, and research teams are working together specifically to avoid false interpretations caused by instrument errors or isolated observations. The coming hours may reveal nothing more than a fascinating comet from another star system. Or they may force astronomy to ask new questions about how interstellar objects form and behave. Either way, this encounter represents a rare moment when humanity gets to observe a visitor from beyond our solar system at extremely close range. As new telemetry arrives from Mars, researchers and skywatchers alike will be waiting to see whether this mysterious green traveler behaves like a natural wanderer of the cosmos or something far more unusual. For a brief period after the flyby begins, silence will become part of the story. Signals from Mars orbiters will not arrive instantly. Every image, every spectrum, every particle reading must travel across millions of kilometers before reaching Earth. That delay creates an eerie gap between the event itself and humanity's awareness of it. Somewhere near Mars, the encounter will already be unfolding while scientists on Earth are still waiting for the first confirmation packets to appear on their screens. Inside mission control centers, the atmosphere will feel tense but disciplined. Engineers will monitor telemetry streams line by line, watching for dropped packets, corrupted frames, or sudden spikes in instrument activity. Researchers who have spent months debating theories about 3I, ATLAS will suddenly be forced to stop speculating and confront real evidence. The first data expected back will likely be brightness measurements and navigation tracking. Those readings alone could reveal whether the object remains stable or begins to break apart. A sharp increase in luminosity could indicate a major outburst of gas and dust. Multiple moving light sources could signal fragmentation. Even a subtle deviation in its predicted path would immediately attract global attention. Radio observatories will also play a critical role. As charged particles from the object interact with the solar wind and the Martian environment, unusual radio emissions may appear. Scientists are especially interested in low-frequency bursts and repeating patterns that could hint at magnetic interactions far more complex than ordinary comet activity. If fragments pass through the upper layers of Mars' atmosphere, orbiters may detect temporary chemical changes. Instruments designed to study trace gases could suddenly register spikes in ionized particles or unfamiliar compounds. Such readings would not prove anything extraordinary by themselves, but they would provide valuable insight into the object's internal composition. The real challenge begins after the first excitement fades. Raw data must be calibrated, compared, and verified independently. A single strange reading means very little until multiple instruments confirm it. Scientists know how easy it is for noise, glitches, or statistical anomalies to create misleading impressions. That is why the coming days will matter more than the first headlines. Public reaction, however, may move much faster than science. Social media channels are already filled with dramatic theories claiming the object is a probe, a hidden spacecraft, or evidence of extraterrestrial intelligence. Experts continue warning people not to mistake uncertainty for proof. History shows that many mysterious cosmic events eventually find natural explanations once enough data becomes available. Still, even cautious astronomers admit that 3I, Atlas is unusual. Its chemistry, brightness behavior, and orbital geometry place it among the strangest interstellar visitors ever observed. Whether those oddities represent unfamiliar natural physics or something more surprising remains completely unknown. As Earth waits for the delayed signals from Mars, telescopes across the globe will continue scanning the sky for any visible change. Amateur observers may notice sudden flares before official reports are released. Automated observatories will compare images frame by frame, searching for faint fragments or unexpected motion hidden inside the comet's glowing coma. The most important principle guiding tonight's observations is simple: evidence comes first. If the object behaves naturally, scientists will learn valuable new information about how other star systems form comets and distribute organic material through the galaxy. If the data refuses to fit existing models, then astronomy may face a much larger conversation about what truly travels between the stars. Either outcome expands human knowledge. Either outcome reminds us that the universe is still capable of surprising the species that believes it has already mapped the sky. Hours after the closest approach, the first serious analyses will begin to emerge. Not dramatic declarations. Not confirmations of impossible theories. Just cautious scientists comparing numbers, checking timestamps, and asking whether the strange patterns seen before the flyby still remain afterward. If 3I ATLAS survives intact, attention will immediately shift toward its internal structure. Researchers will study how efficiently it reflected sunlight, how much mass it lost near Mars, and whether its strange pulsing behavior changed under stronger solar heating. A normal comet should gradually calm as gases vent into space. But if the rhythmic brightening continues with unusual precision, it will remain one of the biggest unresolved questions surrounding the object. The dust itself may become one of the most valuable discoveries. Early observations already suggested the presence of unusually large grains moving at unexpectedly slow speeds. That matters because ordinary comet dust is often fine and chaotic, shaped mainly by solar radiation pressure. Heavier, more organized particle flows could point toward unfamiliar material properties or unexpected internal mechanics. Spectroscopy teams will focus heavily on isotopes. Ratios of carbon, oxygen, nitrogen, and rare metals act like fingerprints revealing where an object formed and what conditions shaped it. If the isotopic signatures differ sharply from anything commonly found in our solar system, scientists may finally gain direct evidence of chemistry born around another star.